Howdy and welcome back. So I figured we could go ahead and end this with a brief kind of walkthrough, or I guess tinker around with this together. So as I'm typing up here, you can go ahead and follow along with me in the playground activity directly below. So just to ensure, I guess we're kind of starting at the same page, I'm going to go ahead and start out with int I is equal to 7. Simply created introduced a new object into this program. It's not going to do much, but the object is named I. It's bound to some object out there in memory. That's going to be initialized with 7. Now, if I see out I, you would expect when we compile and run this to see the integer value of 7 written to the terminal. We can ask I where it lives by, I'm first going to put a tab to separate out the integer value from the address of I. So to get the address of I, simply ask it with the address of operator, ampersand I. Now if I go compile and run, you can see here that that is the address of the object to which I is bound. So I is simply just another name for this integer object residing out there in memory. Now let's go ahead and introduce a pointer. So let's say P is a pointer to an integer object. Let's initialize it with the address of I. And we'll go ahead and copy and paste this just to make it a little easier. And let's put in some descriptive helpful information here. So I's, I'll go ahead and back that out. Okay, so I is equal to some value. Let's say the address of I is some other value. Compile and make sure that looks okay. So I would get the value of 7, ampersand I. Let's see, address of the object to which I bound. Let's do the same thing for P. P, and then the address of P. So, as you might presume, at this point, P is going to evaluate to the address of I because that's its value, and P will have its own address because it's an object in its own right. So, as we can see here, P does indeed store the address of I, and P does have its own memory address as well. Now, if we wanted to go out and say, indirectly access the object to which P points to, we could start out by just simply saying or printing out that value. So we could say dereferenced P, just put out that value. Compile, run. We can see here that when we dereference P, we indeed get the value stored in I. Now we could do something like dereference P. That effectively gives us the object I because P points to it. So we can indirectly access I through P. Let's go ahead and assign it the value of 11. I'm going to go ahead and copy and paste some of my print statements here, just for some comparison. I'll go ahead and add in just a little bar to separate this. So before and after the assignment. Compile, run. We can see that after our assignment, I has indeed taken on the value of 11. I's address has not changed. The value stored in P has not changed. And the address of P has not changed either. The only thing that has changed is the value of I. And again, because P points to I, we can indirectly access I through P. So Go ahead and tinker around with this a little more in the playground activity below. Hopefully it'll prove, somewhat helpful in understanding the differences between uh, the asterisk appearing in a declaration versus as an operator in an expression. And, maybe walking through this with you a bit more will also help you understand the level of indirection that a pointer affords.